Hi. Hi, today we shall be developing non-recursive model under structural equation model environment. Then non-recursive model means path diagrams have feedback loops, while those that do not have are called recursive model. And here we want to check whether two observed variables such as cells and complaints have feedback loop, meaning that cells causes complaints while complaints causes cells. So, so this is a non-recursive model due to bidirectional associationship. Okay, here I have collected data from 17 computer makers and information about computer to develop non-recursive model. We have the variables such as price, repairs, and size as exogenous variables. And here repairs is a common variable for both the model. Okay, and here is our model number 1, and here the cells actually is the endogenous variable or dependent variable, and the price and the repairs are the exogenous variable or independent variable. And our second model, the complaints is the dependent variable, and repairs and size are the independent variable. And here the repair, this variable actually a common variable for both the model. And here we shall evaluate the model on the basis of following model fit criteria. Okay, so the question is when a model is good fitted, right? Okay, a model is good fitted when number 1, the chi-square, LR chi-square should not be significant, or the value of RMSEA should be less than 0.05 or CFI and TLI close to 1, right? So actually there are many criteria, but here I have chosen only 3 criteria for a good fitted model. And finally we shall check the stability index of the model and also Wald test. Okay, here actually what is happening, the sales is our dependent variable and price and repairs are the independent variables, and complaints is the dependent variables, repairs and size of the computer is the independent variables. So actually our model actually like this. This is our model. I make it big for you, right? This is my model. So here you can see the sales is the dependent variable or endogenous variable, and the complaints is the uh, no, here actually here it's actually the complaints is the endogenous variable or dependent variables, and price and the repairs and the size of the computer are the independent variables. And here this variable which is repairs, this one is the common variable for both sales and complaints. Okay. And you can see there is a row arrow, right? So from here to here this arrow means sales causes complaints from the customer, and this arrow means complaints causes sales. So actually there is a bidirectional causality. So this type of model actually called non-recursive model when there is a bidirectional causality like this. Okay, and here what I am doing, I can show you all my data that I have. My data are here. I can show you my data. It is not okay. Yeah, yes, it is here. The data is here. You can see all the data is coming up. I make it big slightly. Okay, I make it view. I make it big slightly. So okay, I go to view to make it okay. Okay, so actually this is data. Number one, computer maker. So here you can see there are 17 computer maker. You see 17 computer maker, right? That is the first one. Then actually it's a tot, kk, lao, dp, dfg. These are all computer makers. And the second one is the cells volume, and the third column is the price of the computers, and the fourth column is the number of repairs, and number five is the number of complaints about the computer, and finally the size of the computer. And I have collected this data in a particular year, right? I have collected all this data in a particular year, right? So meaning that actually these data that we have actually this data is actually cross-sectional data at a particular year, such as 2012. Okay, now we can develop our model. We can estimate all the variables now. Okay, so this is my model, right? So I go to estimation, I go to estimate, right? Okay, then everything is set. So there are three methods. So the first method is maximum likelihood. So I select OK. So yes. So I select OK. So so these are the outcomes have come out, right? I can make it further big for you. So actually these are the coefficient, right? These are the regression coefficient, right? All these things. Okay, so this is my outcome of the result, and also the result is here. Result is given here. The outcome has come here. Okay, and here we have actually estimated unstandardized, right? Unstandardized estimates, right? This is unstandardized estimates. Okay, and here you can see our model is like this. The endogenous variables, cells and complaints are the endogenous variable, price, repairs and size are the exogenous variables. And you can see, so this is our model, and so here the cells is the dependent variable, and complaints, price and repairs are the independent variables. And here again complaints is the dependent variable, and cells, repairs and size are the independent variable. Okay, and finally, so actually we want to check which variable is significant to explain dependent variable. Okay, so first I check complaints. Is this variable is significant to explain cells? Okay, here is the probability value. So probability value is 54.6%, which is more than 5%. So meaning that complaints is not a significant variable to explain cells volume. Okay, then what about the price? Right, price, is it significant? The probability value is 0.7%, which is less than 5%. So meaning that when the probability value is less than 5%, then that particular independent variable becomes significant, meaning that price is a significant variable to explain cells. And finally, number of repairs, right? Number of repairs, is it significant? The p-value is 24.1%, which is more than 5%, meaning that repairs is not a significant variable to explain cells. Okay, then we come here. Okay, here complaints now is a dependent variable, and cells, repairs, and size are the independent variables. Okay, here the cells what is the probability value? 19.4%, which is more than 5%, meaning that cells is not a significant variable to explain complaints. Then the second one, repairs, is it significant? Probability is 31.6%, which is more than 5%, meaning that repairs is not a significant variable to explain complaints. Finally, size, what is the probability value? 45.4%, which is more than 5%, meaning that size is not a significant variable to explain complaints. So here actually only the price is a significant variable to explain cells, right? Only price is the significant variable to explain cells. And our model, you can see here, cells is not a significant variable to explain complaints, and also complaints is not a significant variable to explain cells, meaning that there is no bidirectional causality from sales to complaints and vice versa, right? So there is no bidirectional causality from sales to complaints and vice versa, because here only one variable is significant, that is price, to explain sales, right? Okay, now it is done. Now we talk about model fit, whether the whole model is properly fitted or not, right? Model fit criteria, right? Model fit criteria, and we have actually three criteria. We have some criteria. So actually the criteria is like this: the LR chi-square should not be significant, and the value of RMSEA should be less than 0.05, and CFI and TLI should be close to 1, and only then a particular model is a particular model is a fitted model. Okay, now I check about our model. Okay, first I check about the first criteria, whether LR chi-square and the probability value. How much is the probability? 45.41%, which is more than 5%. That means our first criteria, which is LR chi-square, is a non-significant, right? The first criteria is LR chi-square, which is non-significant. So meaning that our model is fitted because it is non-significant, 45.41%. So we are happy about the model because the model is fitted. And we have some more criteria. So we check all the criteria that we have. Okay, go to estimation, goodness of fit, and overall goodness of fit. I select it, and here you can see statistical to be the goodness of fit, right? And here are many criteria. I choose all of the above, right? I choose all of the above, then press OK. So the result is coming up. You can see the result, all the result. Actually here are many criteria, right? Many criteria. So this one is the first criteria. Yes, it is non-significant, meaning that model is fitted. And second criteria, we say the value of RMSEA, right? If the value of RMSEA is less than 0.05, then the model is fitted. And here I can see the value is very small, less than 0.05, right? So meaning that our model is fitted, nicely fitted. And the third criteria we have chosen here, that is, we said if the CFI and TLI is close to 1, then the model is fitted. And here you can see CFI is 1, but TLI actually not close to 1, right? The value is not close to 1, but CFI is exactly 1. So, but the thing is that the chi-square value, the first criteria, which is chi-square criteria, and second criteria is RMSEA. So according to these two criteria, model is fitted. So I think we are happy about this model, because at least two criteria is saying that model is fitted, and also CFI is 1, meaning that also model is fitted. So we are happy about this model because the model is fitted. Okay, now I check stability index, whether this overall model is stable or not. Okay, so I check the stability index. To check it, I go to estimation, I go to others, then I select assess stability of non-recursive system, right? I select it and check stability of non-recursive system, then I press OK. So the result is coming up. You can see the result. Stability analysis of simultaneous equation system, eigenvalue stability condition, stability index is 0.3451, and all the eigenvalues lie inside the unit circle, meaning that our model actually is a stable condition. That means we can trust all the parameters that we have estimated. So we are also happy about the model because the model is in the stable condition. Okay, finally we check Wald test. Okay, what is Wald test? So what is Wald test here? Right? Wald test, that means joint, it means joint significance test, right? Joint significant test. So actually it is meaning that, so it is meaning that whether price and repairs jointly can cause sales or not. And also we can check whether size and repairs jointly can cause complaints or not. So that we can check using Wald statistics. Okay, so we check it. I go to estimation, I go to goodness of I go to the testing, then this is Wald test, right? Wald test. I select this one, click on it, then this is the this labels, all the coefficient are 0, right? So this one is the null hypothesis, right? This one is the null hypothesis. So I select OK, right? And the result has come up. You can see the outcome of the Wald statistics. So you can see the Wald test for equation, and the cells is the dependent variable, and complaints is the second dependent variable, and here is the null hypothesis. Okay, so first I talk about this one, cells. What is the null hypothesis? Price and repairs do not cause cells, right? That is the null hypothesis. And what is alternative hypothesis? Price and repairs can cause cells. Okay, and here you can see the probability value is 2.01%, right? 2.01%, meaning that less than 5%, meaning that we can reject the null hypothesis and can accept the alternative hypothesis, meaning that price and repairs can cause cells, right? Price and repairs jointly, I should say jointly, right? Jointly, I should say jointly, right? Not individually, jointly. Price and repairs jointly can cause cells because the probability is 2.01%, which is less than 5%, meaning that we can reject the null hypothesis and can accept the alternative hypothesis. Okay, then we talk about second one, complaints. What is the null hypothesis? Here you can see our variables are like this, size and repairs, right? These are the two variables. So size and repairs do not cause complaints. That is our null hypothesis. And alternative is size and repairs jointly can cause complaints, right? And here the probability value, the p value, right, is 21.78%, which is more than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that size and repairs jointly do not cause complaints, right? So that is the decision of the model. So I am telling again, so from here, from this Wald test, we can see price and repairs, these two variables jointly can cause cells, but repairs and size these two variables jointly cannot cause complaints. So that is the decision of the Wald test. And thank you very much for being with me for a while.